Before I dive into the subject, who of you tried the RESTful service support in DB2? You did? Few? Okay. So So the question is, who of you already worked with the RESTful service support in DB2 and has personal experience? Yeah. Okay. Okay. It's good. Because I would be interested in your feedback as well when we get into the details. So, as I said, we want to discuss about the RESTful service support as now stops to work. Okay. I think my whole PC. Okay. I have no clue why it didn't work. So what I wanted to cover in this presentation are three topics. One is give you an overall context why this functionality is so important and how it fits into the bigger picture. And the second topic is give you a very short introduction on ZFS Connect, because it plays a role in this bigger context. And then I go into fairly deep technical detail on the RESTful service support in DB2, and it's in DB2 version 11 and in DB2 version 12. Okay? So it's not in version 10. Version 10 still has an old support. It's DB2 adapter for ZFS Connect version 1, but we do not encourage people to use it any longer. We encourage to use version 11 and version 12 anyway. Okay, so the bigger picture is actually very interesting. About 10 years ago, there was this big momentum about service-oriented architecture. You may still remember this. The main technology driving this was SOAP as a communication protocol and XML to describe the payload. And the big selling point was that both technologies were platform agnostic. So you could actually combine programs together that could not talk up to that point, and therefore empowered you to create modules and connect them. At the same time, the mobile technology picked up, and they liked this technology because it's platform independent, but SOAP and SOAP and XML was much too heavy to be processed on a mobile phone at that point in time. Okay, so they took the technologies and optimized it, and this is what led actually to REST APIs. Okay, so the mobile adoption really put momentum on it to exploit it, but then after you saw the people saw the flexibility of those RESTful APIs, they said, wait a moment, I can actually connect requests that run on-prem. I can with requests that run in a public cloud. And certainly we had speed in cloud enablement, because this technology actually enabled public cloud and hybrid cloud scenarios. And then when you look at this, a lot of APIs got actually provided on the public cloud, and it was not just transactional, it was analytical service. One example is the sentiments APIs that IBM offers as an API on the IBM cloud, so where you can put in a text and you get out as a result in which mood the person was who wrote this article at the time he wrote it, because you can actually detect it from the words and the sentences that were used. And it said, you know, it was really bad mood or stressed out or whatever. And you can actually use this, and it is used in medical applications, that they determine the sentiment together with your blood pressure and medication you take, etc. It's actually really, and it's true use cases. I mean, it's not made up. So it's really interesting how you can certainly combine certain applitions in one context, which now drive completely different business use cases. And this is basically on the bottom, a technology enabled new business use cases. And this is why, and you hear this now under digital transformation, but that is really what it is. And when you look at the cool startups, the disruptor in each of the industry, this is what they or how they differentiate it. Look at Uber. I mean, Uber is nothing special. It uses Google Maps to display where your little car is. It integrates with a merchant's API, so you can charge on your credit card. PayPal offers it. Actually, I think every bank should offer it nowadays. And so it has a cool user interface with a couple of technologies that's around forever, and it disturbs the industry as a new business model. And you can go in any industry. The fintechs are the same way. So you combine banking APIs and give you the ability as a consumer to go across different banks and look at your financial portfolio in its entirety instead of going to 10 different web pages. So it's technology in this case really drove new business use cases, and those business use cases actually disrupt existing companies in every industry. Banking, distribution, insurance, transportation, you name it. I mean, it's everywhere. So this is why it's really, really important that you know about it. And actually, I like to ask you to lobby for adoption of this technology in your company. So, okay. So this is one example which really appealed to me. It's out of the insurance company, and it's actually a hybrid cloud use case where different APIs are connected to bring up a new business use case for insurance. So it's very easy. Up here, you have a system of record data, and this is the driver and the risk, the car. And then you have public data, which is the device driving behavior that a lot of cars already have. And actually, it's not that you need to put it in the car. As soon as you sit with your phone in the car, you are actually providing driving behavior information. This is how Google determines if you have a traffic jam or not and marks it red or yellow because you have your phone with you in the car, okay? And then you have weather information that is publicly available, and geospatial temporal information. Combining those together, you can actually predict your driving pattern. So if you go on this road with a very high likelihood you drive to work because you do it 5 days a week, or you drive your kids to school. And then combining this with a weather pattern that goes along, the insurance company can actually predict that you very likely drive through this hurricane area or through a thunderstorm or through a hail. And they could actually call you on your phone and say, can you go on this parking lot? There's a Starbucks. We give you a coupon. Just get a coffee and wait it out. Because the chance that you have an accident because of the constellation is very much higher than a normal risk. And therefore, by managing the risk, the insurance company manages its business effectiveness It saves you a lot of trouble, because if you have an accident, it's always annoying, more than annoying. So it's a win-win-win situation just by putting the different information together. It has some concerns, because do you want to have someone know where you go all the time? I mean, there's some data privacy involved, definitely. But from a technology perspective, it's actually doable, and it's doable because of this ability to combine completely different information, different data through API, so it doesn't matter where it runs, you just have to connect it. And to be honest, to put such an application together from a user interface, a programmer can do it in half an hour. It's not a lot of coding, because the tools are available to generate this code. Okay, the majority of the user interface code is actually generated code, and you just have to have a designer who makes it cool looking. Okay, so this just to give you the big context, it's everywhere, and it's actually cool. So let's go now into the underlying technology. I mentioned REST and JSON. REST, see it as a cheap communication protocol. It's actually also based on some JSON semantics. And JSON is a cheap XML. It's called JavaScript Object Notation. And it actually is a structured name-value pair, or a structured collection of name and values that have described the meaning. It evolved actually into an architectural style because you can actually express insert, update, deletes, and retrieves through this REST API. So let's look at it in an example. So you have the HTTP verbs for create, read, update, delete through get, post, put, and delete. Okay? And then you see, let me just get, you have a URL. This tells you where the service is located. And this can be your C system, it can be URL on your public cloud, and it can be URL which is actually going to your PC. It's just a URL. And then you have name-value pairs as parameters. And then you get an HTTP response which tells you what is the return code, and then in the body it gives you the reply. And in the specific example, you request the information for name, for department name, and you get the department name with the description back in the body. And this is basically an example of JSON. You have a name and a value. And it's structured through this parentheses and commas, so you can actually build up a tree structure in any level of detail. Think about hierarchy, IMS. It's actually the same thing. It's just expressed differently. Okay? So that's actually all. It's very simple. And that's why it's so cool and so powerful. The simple things are the most powerful one. So now let's go into ZFS Connect. Who heard about ZFS Connect before? 1, 2, 3, a few. So ZFS Connect is the C platform product that enables every subsystem as API, as REST API. Okay? A lot of companies already adopted it as a standard way to provide existing assets on C as an API. And it can include KICS transaction, IMS transaction, WebSphere application, MQ, DVM, Data Virtualization Manager, and a DB2 call that is RESTful enabled in DB2. Okay? So see it as a single entry point into all the assets that you have on your existing mainframe API enabled, so they become available in this new infrastructure. So think about the driver and risk information. There is very likely a transaction sitting in every single insurance company that retrieves a driver and a risk. You API enable it, give it to the application programmer who wants to have also this cool application design, and he calls the API. He doesn't have a clue that he calls C in the first place because it's just the URL. He doesn't have a clue that it's a KIX transaction, and he doesn't need to know how to call a KIX transaction because he only sees HTTP and REST. And actually, most of the time he doesn't even see it because it's tooling that generates the code, so he just plugs in his GUI. Okay? It comes with a lot of additional functionality to actually implement it in an enterprise environment. So it's security, auditing, problem determination, all of that. It's pretty comprehensive in ZFS Connect. And it also has, which is very important, the support for Open API. And I go into an example a little, but Open API is basically the open source, de facto industry standard tooling to detect an API and generate the client code. Okay? And you can generate the client code in the language of your choice. That's why I'm saying it's very efficient and cool because you don't have to code anything any longer. You detect, generate, and plug it in your GUI and you're done. Okay? So that is a really important point because DB2 RESTful service support is not providing the Open API support. We rely on ZFS Connect to provide this capability for the entire platform. It doesn't make sense that KIX implements it, WebSphere implements it, and DB2, so ZFS Connect does it for us, okay? And that is a very important integration point between the DB2 RESTful service support and ZFS Connect to give this capability. So just I covered it somewhat, so you basically can support KIX, IMS, DB2, MQ, DVM, and actually you can use it as a REST gateway as well to call into another API. And it has a lot of enterprise functionalities that you need to maintain it. So the idea is there is this humongous amount of assets sitting on your mainframe in all forms and shapes. API enabling makes all those assets available in the new environment to create new mobile applications for basically in the entire digital transformation roadmap. Okay, and you know how? Just think about the banking case. It wouldn't make sense to rewrite a bank transfer transaction. It's done already 100 times. It's optimized. It runs. It scales. Bringing it into the new world is all you need to know. Okay? So, Open API, you can actually look it up in Google. It has a couple of components. You can actually detect a service with it, and it pulls in all this metadata information in this structured form. And when I talk about metadata information, just think about you want to consume a service. What would you need to know? You would need to know the URL, how to call it. You would need to know what input you have to provide, and you would need to know what output comes out of it and the function it does. And that is all detected by Open API. And then you can consume this description with the language of your choice, and it generates you the calling code. Okay, so it generates, and then you get basically a method, and you plug in this entry field, which gives you the driver name, becomes a parameter in your RESTful call, and everything else is under the cover. Okay, really cool technology and widely adopted in the application development community. So that's pretty much all what I wanted to cover about ZFS Connect. So you can position it, and then let's now go into DB2 RESTful server support. I already mentioned we went through an evolution. So we had the DB2 adapter for ZFS Connect as a first version. This was actually outside of DB2, and we determined it's not as efficient as we could do it. So that is where we came up with the RESTful service support, which is functionality in the distributed address space. Okay, so it comes out of the box with DB2.11 and DB2.12, and it reuses all the distributed functionality and optimization we put in over the last 5 versions of DB2, so you talk about 15 years and plus of technology and optimization. It's all used. We introduced a new RACF profile, so you can actually define for your dist address space for a given DB2 if this DB2 is allowed to receive RESTful service calls, or just traditional DRDA calls, or if you do not start up this address space at all, it does not receive any distributed requests. So it's your control, and if you are in a data sharing environment, or your environment is a data sharing environment, you very well may decide one DB2 member has a dist address space with the authority to receive REST calls, and the others may not. You can segregate until you feel comfortable. And I still see this in a number of installations that they have specific DB2 members set up to work on distributed requests versus other members just solving the local kicks, an IMS workload or batch. Okay? So you can, in a very controlled way, get this functionality into your DB2 if you're on data sharing. So it's a RACF definition example is here. The next one, client info fields. We tell everyone, especially in this Java space, and you will hear me talk about it tomorrow in my presentation about Java best practice. Client info field is a very powerful way to get application information into DB2 for workload management, problem determination, monitoring, you name it. It's everywhere. So we actually, in this context, we followed our own recommendation. So the RESTful server support, by definition, fill and use the client info fields. And I show you an example later in the screenshot. You can, if you do a display thread detail, you actually see if a thread in DB2 is used by a RESTful service request, what is the service, and all this additional information. So it's very transparent to you. Okay? So if such a RESTful service creates a problem, you can know exactly which thread to cancel and not impacting all your other work you're worried about. Okay? And from a implementation perspective, RESTful services are special packages. So think about, you have a trigger package, a stored procedure package, now you have a service package. And it's in this new catalog table, this IBM DSN service. It's maintained, and it's executing static SQL. There is a way how you can execute dynamic SQL, but it doesn't make sense. Because just think about the idea of a RESTful service. The implementation should be covered it shouldn't matter. As soon as you have an SQL as an input parameter, it's clear the implementation needs to be SQL, needs to be a database. It doesn't make sense. It's actually against the paradigm of a service. Okay. The nice thing with this is because it's static SQL, we can actually do object dependency checking in DB2. It means if you drop an index, you know which services go out of, are not functional any longer, and you can actually do a bind of those service packages, and then they work again. Whereas before, if you did work in DB2, the service definition didn't have any idea, and the problem was only detected when the service was called, and then of course you have typically a problem. Okay, so this dependency checking is really nice from an operational behavior to keep your services up and running, because you have no clue who consumes them. So those are truly 24/7 function you want to provide. So how does it work? I already mentioned the syntax of an HTTP request with a URL and a function name, and then you provide an input in JSON format. It comes into this address space, and it's parsed and security checked, and then everything that we do in this address space today about creating a thread, executing SQL, it's all the well-beaten path. Nothing is new about it. Actually, the new stuff is only this component. So just think about before DRDA came into this address space, which is one format. Now HTTP JSON comes in, and the parsing is different, but what comes out of it is actually the same, and then it follows the parse. And then when the SQL is executed, in this example, it's a select balance from bank account where an ID is a value. Then on the response, you get in the body, again in JSON format, the balance as a name and the value, which is an amount. And you get the HTTP response code as well. Okay? It's really simple, but it's cool. Okay? So how did we implement it? And actually you saw it already mentioned here. There are 3 stages. You discover, as a consumer of this RESTful service, you discover the service. So you understand, oh, this service does A. Oh, I need A. And then, oh, this is the input, this is the output, this is the function. And then you can manage it. And the last one, you invoke the service to actually execute it. And we implemented in DB2 those RESTful services through DB2 provided services. And one is DB2 Service Manager, which has a request type, which is a create service. One example is a create service, or you can drop a service. And then you have another service, it's DB2 Service Discover, which is actually called to get all this metadata information. And again, you give it information about what service you want to have the details on. And then, of course, the last one is you call your service. So you use services in order to work with the services, which worked really great. We saw a very interesting adoption phase. In the beginning, you can just plug this in any browser and do this, connect to DB2 and execute it. And everyone felt comfortable about it. And guess what? What happens? After, I think, about 9 months to a year, we suddenly got a request. We are ready to deploy those services in production, but this approach with the service definition doesn't fit into our change management. So you knew all the development phase was somewhat okay, and now they wanted to deploy it. So now the operational considerations came along. And that actually led into enhancements in DB2, which I will cover in a second. So here's an example for DB2 Service Manager. The input is create service. It has the SQL statement as an execution. It could be an SQL statement, or it can be a stored procedure call. So if you want to combine multiple SQL in a more complex logic, just put it in a stored procedure. And then you call the stored procedure, you give it a service name, a description, and you may define a version if you want to. Okay? One question for you, what is the transactional scope of a service? Any idea?
Transaction will complete all in one shot.
Yes.
So it's not like opening a pipe and running multiple.
Exactly. So by definition of a service call is stateless. So you cannot have a unit of work across multiple API calls. Okay, so each API call in itself is a transaction for DB2. And then, of course, we got the question, oh, but I need to do multiple things in a transaction scope. So if you want to have a transaction scope in a service, put it in a stored procedure, and then the service has a more complex functionality. But at the end, there's no hold cursor position, there's nothing sitting around. DB2 completely cleans up when the service response leaves the system. Okay? I think it's an important way. And then down here you get, again, the HTTP code to warn that the DB2 RESTful service was successfully created, and it gives you the URL of the service call. Yep?
Can you go back to the previous screen?
Yeah, sure.
Actually, one more. This is, I might have a mental block, you might have said this. So, I'm trying to figure out where ZFS Connect fits into this, and my URL is the DBF address space, not ZFS.
Hold on to this question. I have a chart on this.
Oh, okay, great.
Okay, good question. And you're not the only one who is asking it, and that's why it's coming. Okay? So that makes sense. So if anything goes wrong with the SQL execution, where will you see it? It's down here. So there is a documented list of HTTP return codes, and if you have an error message, the status description will give you the DB2 message, the reason code, and all the information that you need in order to debug it. So that's a question I also get frequently. Oh, if something goes wrong, how do I find out what went wrong? It's in the HTTP response where you get all the information. Yeah? Where's the version this version comes from? Hold on to this question too. You're all ahead of me. I need to speed up now. Okay.
From a mainframe brain, will this give you like table.payload or
Yes.
So it'll actually give you the entire DB2.
Yes.
SQLCA tells you it'll.
Yes. So you will get an HTTP code, which is not an SQL code, but in the documentation, when you go to the Knowledge Center, there is a mapping between the HTTP code. For example, 201 is success, 200 is success for a GET. And then in the status description, you get the DB2 message, reason code, and the message text. So if it's table not found, or whatever the return, we have 1,000 messages. You would find it here. Yes. Yep. So there's no reason to worry that you cannot detect problems, or it's actually all in here. Okay? So I mentioned that we went through this evolution, and guess what? We implemented a bind command, bind service, because bind is well established in all of the change management. So that is the way how the services get deployed from one environment to another. And you can actually do a rebind service as well. So when you do a bind service, collection ID, I talked, every service is a package. You can bundle it in a collection ID. You have a service name and the SQL name, and it can be provided via different means. And it also supports this long list of bind clauses. So you can say, with your, whatever the bind commands are. So there's a long list, and the majority is actually applicable here as well. And you can free a service by a free service command. So I give you the APOS for this functionality. I mean, it's about 9 months old, almost a year now. So some of you may have it already, but others may not. Okay? But this really came in, not in the beginning, but well into the functionality to figure out how to do all the change control and automatic deployment. Okay, so this is an example down here. You have the name of the service, the encoding would be in bind command, description. So you have it all there. And it looks like a very normal bind. Okay? So this is the example for display thread detail. Just to give you, normally you would see this line. You see it's a thread ID. If it's in DB2, what is the auth ID? But I mentioned we give you the client info fields. It's a workstation, which would be, in this case, is a browser where the service request was executed from. The user ID that, so to execute a service, you have to sign on into DB2 from your browser. And it gives you, under application names, the service name. Okay? And the accounting gives you the whole service call. It's a POST, this IBM service simple select in this case. So when you do a display thread detail, you see exactly which threads execute a RESTful service, so you know what to do with it. Okay? And actually in all nice details. And you can run a DB2 PM report and say order by transact, and you get actually your accounting information sorted by a service, for example. So you know exactly how much resource a service consumes. Or you can actually do workload management definition based on one service versus another service. It's all possible. So it's really enterprise grade functionality. Yes? Yes, so the application name, and it's documented in the knowledge center, because DB2 sets all those names. So the application name is the service name that you defined. Okay? So the next one is versioning. So you know we have versioning for stored procedures. We have now with DB212 versioning for trigger, for the new style trigger. And we have versioning for services. The versioning for services are somewhat different because you can have a varying amount of input and output in your service call. I think there's an example coming. So it means you have to define the version that needs to be called, otherwise it always goes back to the default version. Okay? So, but you can have one version of a service out, and then you find, oh, I need to get one more input parameter to do certain functionality. So you can come up with a new version of the service, give it a version name, and then you give this version name out, make it ready for discovery, and then some other application will use the new version of the service. Okay? So it's not this, when you look in stored procedure where you swap to the new version and it's called implicitly. Here, implicitly, it's always the default or the first version of the service, and then you have to explicitly call the next versions of the services. I just want to contrast this because even in our technical community, people were a little irritated how this versioning works. So it is different than the stored procedure versioning, but there's a very good reason why it is different. Okay? And here's an example. So we have the service is the URL, service name, and create, and version 1 would be the default version. And in this one, the email was added, it becomes version 2. And then in this example, it uses a different SQL statement, so it's a version 3. So it's the implementation can change, input can change, everything can change, basically. Okay? But it gives a lot of flexibility in this agile way of how those services work.
So the other versions are still valid?
Yes, until you freeze them. Yes. You can call any version, or any version would be valid and available and can be called. And if you want to sunset a version, you actually stop the service, so it cannot be called. And people get a message saying the service is not available any longer, so they can switch to a new version of the service, and then eventually you free it, so it disappears completely. Yep, good question. Thank you.
So it's 3 packages. You have 3.
Yes, every service has its package. So every version has its own package. So you would have 3 packages for the same service. 1 package for version 1, 1 package for version 2, and 1 for version 3.
Is the version on the service the same thing as the version on the package?
Yes, I think so. Yeah, because it's used to generate the token. Yep. Okay. A couple of details. You cannot, to call a service, you can use both protocol, HTTP and HTTPS. Okay, both are supported. If you use Data Studio to connect and create services, it needs to be HTTPS. Typically, browser use HTTP, it makes it easy. I already mentioned static packages. So from an authorization model, it means the person, DBA, who creates the service becomes the owner, and the owner of the package needs to have the authority to execute the SQL, which is in the service. And then it can't execute authorization to the people who are authorized to execute the service. Okay, so if you give the service out, the people who call the service have no clue and shouldn't have a clue and have no authority to go against the base tables. And that's another reason why you do not want to have dynamic SQL in this context. It doesn't make sense. Okay? Another one, zip eligibility. You already saw the picture. It's going down the disk execution path. So if you use RESTful services, it gives you exactly the same zip offload as any other distributed request. Okay, it's 55 to 60% zip eligibility. You get the same thing. Okay. RESTful service implementation with ZFS Connect. I hold on to this one. There is a story behind this link, and it's a couple of years old now, but I'm still excited about it. When we came out with this functionality, I think about 3 years ago now, this writer of this blog got the PDF applied on Friday and was so excited about that he actually tested it, and wrote the blog over the weekend. And on Mondays, this blog was available. And just go to this link and read about it. It shows the excitement about this functionality and how easy it is to be used and consumed. So it's not complicated. The brilliance is in the simplicity. Okay? Try it out. One comment on HTTPS support. HTTPS is supported on the secure socket in your distributed environment. If you already have it, you don't need to do anything. If you don't, you may consider defining it, but you need to work with your security guys and communication guys, and this red paper and the red book help you to have this communication with your other teams so you know what you are asking for. Okay, I don't want to go into details here, but I want you to understand a secure socket for distributed address space is something you have. It's not defined in DB2. It needs to be defined in the communication server. Yeah? Okay, so now the picture comes for you. So I wanted to compare and contrast. So all the time we had the distributed address space and distributed application. We had an application, and it could be implemented in Java and C, you name it. You had a data server client or a DB2 Connect gateway connecting, and then it was talking DRDA to the dist address space. Okay, and you had to pay a DB2 Connect license in order to have this functionality working. The new alternative is you have this RESTful service, so it's the URL service name and a JSON input, and it can go in two ways. It can go as a REST API to ZFS Connect, and it will have all, for example, the Swagger description, all of the information around. Very likely, and let me explain it in a second, there is some mapping of input and output. And then ZFS Connect actually calls the RESTful service in DB2. And then it comes in as HTTP or HTTPS and JSON, and then it goes away. So it's an interesting, there seems to be a terminology that is in the process of establishing. When we talk to the Kix guy, for example, or the team that manages the ZFS Connect in your enterprise or in others, they created this term of system API. And a system API is basically your Kix transaction or your stored procedure exposed as an API. But it may already hide some information. For example, in Kix, it's a Kix transaction ID, which may be needed in order to call a Kix transaction or the transaction name. A service caller doesn't even have an idea that there is a Kix transaction, not to talk about a Kix transaction name. So you want to hide this and not expose it in your API. But then you have an API, a system API, which has those 5 input parameters, and it gives those another 5 output parameters. The application programmer who writes all those cool GUIs, he may only need 2 and not 5, but he doesn't know what the other 3 are. So there is another virtualization layer in between a system API and actually an API that follows either some industry standard or is consumed by the application. And you have different tools. It's API Connect. You can also do some of the mapping in ZFS Connect. All of this functionality is only in ZFS Connect. In DB2, it's in and out, no description. It's really more for us to have all these internal advantages of DB2, but not to please all the application developers. So if you want to please all the application developer, you really need to go through ZFS Connect. Okay? And then it's from a protocol, it's a gateway. Oh, another thing I need to point out, because I had a discussion with Kyle, who is the DE for ZFS Connect, and he said, you guys in DB2 are not supporting REST APIs. And that is true. You know, when you look at the first, second or third slide where we had the GROT support with all the different verbs, HTTP verbs, DB2 is not supporting any of that. DB2 is only supporting get and post. And in this API mapping, you would map a put with a service call, which could actually be a get. Okay, so ZFS Connect exposes the full REST APIs with all the verbs, and you have to map them in this virtualization functionality to the DB2 RESTful service. Okay, so there's a slight differentiation, but it's actually means a lot. Does this answer your question? Yeah? Okay, good. One thing I wanted to point out, and I think when you see the picture, it's obvious. This guy has absolutely no idea that he talks to DB2 or to ZFS Connect. He only sees a URL and a payload. Therefore, this configuration does not need DB2 Connect, because there is no DB2 Connect client code. Okay? I think it's important because it confuses. Here you have actually DB2 client code, and that is what you license connecting to DB2. In this configuration, you do not need DB2 Connect license. Okay? I know this is a busy talk, but I wanted to give you this information to give you architectural option. Very quickly, it says what the configuration outline is. So this would be DB application, DB2 Connect, TCP/IP coming to DB2, mostly dynamic SQL. And then what the payload is, it's DB2 native data, network protocol, SQL statement coded in a client app, mostly dynamic SQL, zip offload, and how the development skill is. And then we have the different ways. I don't know, it didn't format well. I may need to provide a new version to format this. It looks a little funny. So you would have WAS and WAS Java application using JDBC type 4 going to DB2. It's very easy. Then you have an application to going to the KIX transaction gateway, KIX DB2. Very likely it's static SQL, coded, SQL is coded in the KIX application. It's much more complex and so on. So you get the idea. It's the typical stacks. Now we have two new stacks. It's ZFS Connect to going to DB2, and it's super easy. And you could have ZFS Connect going to KIX and have the ZFS to KIX connection to DB2. It's still very easy because it's just generation, but it's more about maintaining all the assets you have in your KIX transaction. And actually, everywhere where you have KIX, you could write IMS. It's exactly the same. Okay? So it gives you, when you have those architectural choice discussion, it gives you an idea and some categorization, to help you with those discussion. I already mentioned the Knowledge Center because DB2 adopted agile development as well, continuous delivery. All the new functionality is documented in the Knowledge Center. So don't rely on your book that you downloaded 2 years ago. It may not have the functionality that is already out there. Okay? So I like to download the books because I know exactly where I have to look. And I need it for references and syntax. I never memorize it. But in this specific case, it's evolved so quickly that go to the knowledge center and get the information from there. And we continuously add information. And then I want to point you to 2 YouTube videos. The link is in the presentation. One gives you a detailed walkthrough how to define a RESTful service in DB2. And the second one is a detailed video how you expose a RESTful service you have to find in DB2 in ZFS Connect. Okay, there are actually 4 steps that you have to do to get the service definition that is in the package in DB2 into a SAR file into ZFS Connect. Okay, so that is a detailed description. So, in summary, I want you to leave with the information. First, it's cool technology. Okay, it's very much applicable in every single company. You just have to find the right people who drive this agenda. ZFS Connect is a critical part. It provides a lot of functionality, and I see a lot of adoption already, and mostly driven from the KICS guys or sometimes IMS guys. So communicate with them. And the DB2 functionality, even it's new, it's actually a new layer based on existing, well-tuned, scalable, optimized functionality. So this is all ready for prime time. It scales, it performs, and we added, the management extension. So it's you do not need to be afraid to support this functionality if you are DBA or SysProc. You have all the existing power of control. Okay? And that's pretty much it. I really appreciated all the good questions. Thank you. And I enjoyed the presentation.